Introduction to artificial intelligence, machine learning, deep learning, and data science. So, this is a topic we are going to discuss now. Now, before we start, what is intelligence? Intelligence means it is the ability to learn, understand, and think. So, we all have got intelligence with us. So, what do you mean by intelligence? It is the ability to learn, understand, and think. Now, what is artificial intelligence? So, we are making all these things artificially with the help of a computer. That is what is artificial intelligence. So, the computer will be given with the ability to learn, understand, and think. So, that means, in simple words, man made thinking power. That is what is artificial intelligence is. Okay. Now, why we require this AI, artificial intelligence? In some of the situations where human being cannot be go into directly, so in those situations we can make use of artificial intelligence. So to build robotic systems which can work where survival of humans may be at the risk. Okay, so in some of the situations survival of humans may be at risk. In those situations we can use robotic systems to go into that location and do the work for us. Okay, so for that purpose, we can make use of artificial intelligence. So we can give intelligence to the robotic system, so that the robotic system go there and do the work for human being. So for that purpose, we can make use of artificial intelligence. Then, so these are some of the applications only to create softwares or devices which can solve real world problems such as health issues, marketing, traffic issues. So wherever we require the use of artificial intelligence, we can make use of AI there. Then to create visual assistants such as Cortana, Google Assistant, Siri, all these tools work based on the artificial intelligence. So we are using these things in our day-to-day life. We are using Google Assistant, we are using Cortana in our laptops, we are using Siri in Apple mobiles. So where we will make use of this artificial intelligence. So the main use of AI is to make the human being more. Hello, is it visible now?
Yes, sir.
Okay, okay. So to give such type of advantage, we are making use of AI to build robotic systems where human survival is at risk, to create advanced softwares devices which can solve real world problems, then to create virtual assistants such as Cortana, Google Assistant, Siri, etc. So we can make use of this AI in these situations. Not only these situations, we can make use of AI in almost all the situations where we require the use of AI. Thereby, we can solve the issues more easily. Now, some more applications, specific applications, face recognition, speech recognition in agriculture field, finance, marketing, aviation, bioinformatics, mechanical field, civil engineering field. So wherever we require the use of AI, we can use it there. So that means this AI can be applied in almost all the fields. Okay, so what is the advantage of implementing this AI in these particular fields? See, for example, take the case of face recognition. Now we are using this face recognition. I think for the past 10 to 15 years, we have been using this face recognition. Now with the introduction of this AI, the accuracy of face recognition, previously it was below 80 percentage or around 80 percentage. Now with the introduction of AI, this has improved to more than 90 percentage, 95 percentage almost. Okay, so with the introduction of AI, the existing system's accuracy will be improved. Okay, so that is the importance of the use of AI in almost all the fields. Okay, in agriculture, we have the precision agriculture with the help of electronic equipments. We have been using those equipments there. But with the introduction of AI, we can use those systems more accurately. So the accuracy is going to be improved with the help of AI. Accuracy of systems we already have been using will be improved with the introduction of AI. In aviation field, we can use in bioinformatics, mechanical, like product design, machine design, mechanical component design. So wherever we require the accuracy to be improved, we can use AI there. So we will come one by one in our later sessions. Okay. Then, so this is the major classification, how this AI, ML, and deep learning has been classified. So AI is the main branch under which we have machine learning and deep learning. Okay, so AI, artificial intelligence, is the main branch under which we have machine learning algorithms and deep learning algorithms. So that means we will get artificial intelligence with the help of these machine learning tools and deep learning tools. So we have different variety of algorithms available under machine learning and deep learning. So with the help of machine learning and deep learning algorithms, we can have artificial intelligence, or we can make the machine intelligent, more intelligent. Okay. Now, artificial intelligence, it is the branch of science dedicated to create intelligent machines that work and react like a human brain. So that means it mimics human brain. So artificial intelligence mimics human brain by having the ability to learn, classify, and predict and perceive. So these are the functions our human brain is performing: learning something, classifying something, predicting something, perceiving. Okay, so these are the functions performed by a human, an ordinary human being. So all these functions will be performed by the computer with the help of this artificial intelligence. So AI mimics human brain by having the ability to learn, classify, predict, and perceive. It is a branch dedicated to create intelligent machines that work and react like a human being, human brain. So this is what is artificial intelligence is. Now machine learning, as I told you, is a subset of AI, a set of algorithms which is a subset of artificial intelligence. Now, it consists of systems that learn from data and improve performance with experience. Okay, so machine learning is a subset of artificial intelligence. It contains some algorithms. These algorithms learn from the data, the past data, and improve performance with experience. That means it is trying to mimic the human brain. Now, in human brain, how we will learn something? We will learn from the past data, our past experience. Now, as and when we learn something, we will figure out what that particular thing is. And when we learn, when we see more and more such products, we will improve our our performance. That means we will improve the performance with experience. So we will see one by one later. We will see the more detailed explanation of this machine learning later. Okay, how the machine learns something. So that means it consists of systems that learn from the data and improve performance with experience. So that means it tries to mimic the human brain. It will learn from the machine learning algorithms learn from the past data similar to human being. It will try to learn from the past data and improve performance with experience. Now we will see the expansion of this in detail. Okay, we will define this particular sentence in detail. We will come to know what is the actual meaning of this sentence later. Now, the main difficulty with machine learning is feature extraction. Okay, so the main difficulty with machine learning is feature extraction. So, feature means it is actually the input data, the relevant input data. So, we will be seeing what is relevant input data later. We will see what is a feature also in the later sessions. So, feature extraction is the main challenge with machine learning. Now, in order to overcome this challenge, the deep learning has been introduced. To solve the limitations of machine learning, deep learning has been introduced. Now, deep learning algorithms capable to focus right features by themselves. Now, here it was a difficulty. Feature extraction was a difficulty with machine learning, but in deep learning, the deep learning algorithm find out or focuses on right features by themselves. So that means the feature selection is done by the algorithm itself. But here in machine learning, so the user need to specify which is the feature to be taken care of. Okay, that means the user has to give an input which is the right feature. So that should be selected by the user, the programmer. But this is not the case in deep learning. So here the algorithm itself will find out the right features by themselves, requiring a little guidance from the programmer. So there is no requirement for the programmer to give the feature here in this deep learning. So that is the main difference between machine learning and deep learning. In machine learning, the user need to give the right feature, and depending upon the feature selection, the output, the accuracy will vary. Okay. Now, but in deep learning, the deep learning algorithm itself will find out the right feature by itself without any guidance from the program. Automatically, the deep learning algorithms select the features and uh, will do the rest of the actions. We will see one by one. It can solve more complex problems, including operations on image, audio, video. Then it is implemented using artificial neural networks, ANN. Deep learning algorithms are implemented using artificial neural networks. Okay, so this is the comparison about the machine learning and deep learning. So we will compare the machine learning, deep learning with some of the important parameters later. But for the time being, understand these are the major differences between machine learning and deep learning. Now, data science. Data science tries to find difficult but useful patterns from the data using tools in AI, ML, and DL. Now, this is the diagram which shows the relation between all these terms: AI, ML, DL, and data science. DL means deep learning. Okay, so as I told you, artificial intelligence is the main branch, and machine learning and deep learning are the sub branches. Under AI, ML comes, and under that, DL comes. You know what is data science? Data science find out difficult but useful patterns from the data using tools in AI, ML, and DL, using algorithms in AI, ML, and deep learning. So that means the data science makes use of AI, ML, and DL algorithms to infer something, to find out a new pattern, or to find out a hidden pattern in the data. Okay, so that is what is data science. It tries to find out difficult but useful patterns. Why it is difficult means usually the data will be a huge data set will be available. So it will be very difficult to find out the patterns from the huge data set by a human being. Okay, so we can make use of AI, ML, and DL algorithms to find out difficult but useful patterns. Usually, for human beings, such a pattern will be very difficult to obtain from the large quantity of data. But we require those patterns in order to have some inference, that is, useful patterns. Now, for that purpose, we can make use of AI tools, data, the ML tools, and deep learning tools, combinedly known as AI tools. Okay, so these are the major terms: um, artificial intelligence, machine learning, and deep learning, and data science. Any doubt up to this? Any clarification? You can start from here: AI, ML, and DL. Any doubt up to this? No doubt. Shall I proceed? Shall I proceed?
Yes, sir.
Okay. Now, some important terms, some important peculiarities of machine learning and deep learning algorithms. Machine learning algorithms gives good results with small data set, but deep learning requires very large data sets. So what does it mean is, for example, take the case of image classification. Now, where the input is some images and the output will be what is that image? Classified image. Okay, so in that case, we can use of both machine learning and the deep learning algorithms for the same purpose. For image classification, we can make use of machine learning algorithms or deep learning algorithms. But if the image data set is small in size, then the machine learning algorithm gives maximum accuracy compared to deep learning, because deep learning algorithms requires very large data sets. Okay, so image example, you take the case of image classification. For image classification, if the data set is very small, we can make use of machine learning algorithms. If the data set is large, we can make use of deep learning. Okay, so first you have this idea. Don't uh, get confused, because you want to have the classification. Which algorithm should be used, machine learning or deep learning? Now, if the data set size is small, you go for machine learning algorithms. If you have a large number of data available, data means number of images. Okay, so if you have large number of images available, that means large data set is available, you go for deep learning. Now, machine learning algorithms are quick to train. Training the model, the machine learning algorithms can be easily trained, but it is computationally intensive in case of deep learning. The training phase, that is the first phase, is very, very computationally intensive, very much computationally intensive in deep learning. So that means we require sophisticated, high-end computers. The processing speed should be very high. We require some Intel i9 or above computers with the graphical GPUs also in order to train these deep learning algorithms. But that is not the case for machine learning algorithms. We can train machine learning algorithms easily. Quick to train the model, but it is time consuming in case of deep learning, and it is computationally intensive also. We require high end systems, high end computers. Okay, then next important point is need to try different features. So this one I have already discussed. Feature selection is the main drawback in machine learning, but in deep learning, it learns features and classifies automatically. Okay, so this point I have already explained. Here, the feature selection is the main problem. Here, the feature selection will be done by the deep learning automatically. Now, here, accuracy plateaus. That means we cannot increase the accuracy beyond a level in machine learning, but here the accuracy we can get up to 100. That is unlimited in deep learning. But don't judge that this is the good algorithm. Deep learning is good. Don't get like that because I already discussed the demerits. It requires large data sets. That means we should have a data set more than 10,000. Example, not exactly, but for an example, assume that we require very large data set, more than 10,000. Example. In that case, we can make use of deep learning. But the problem is, we require high-end system. But if the data set is small, we can make use of machine learning, but the accuracy will be limited. Okay, so this is performance-wise comparison of machine learning and deep learning. I think this is clear to you. Here, accuracy is unlimited, but at the cost of high-end systems, time-consuming process, and the requirement of large data sets. Now, we will go into detail. Machine learning algorithms. First of all, machine learning algorithms. Now, as I told you, what is machine learning? It consists of systems that learn from the data and improve performance with experience. Now, how we human being learn something? For example, take the case of this object. We know that this is a car. Now, if you are given with a different car, then also you will be able to judge. You will be able to understand this is again a car. This is this one. The third one is also a car. So how we learned this particular thing? How the human brain learns something? Because in our childhood, we have been taught like that by our parents or by our instructors by showing some objects. See this object, we have been instructed that this is a car. This is also a car. This is also a car. So whenever a new car comes, so we will automatically classify it as a car. So this is how we human brain, we human being learn something, and we will have the prediction. or classification. So here we are classifying things. Now this is a car, not a bicycle. Okay, so this is how we human being learn something. Now in the same fashion, the computer also learn, or the machine also learn. So how this machine learn something? No, we will train the machine. See, these are different images of the car, different types of cars. So we will feed or we will train the machine by giving these available pictures. Okay, so at the training phase, that means at the learning phase, the computer or the machine will be fed with the images of car. Okay, now after training phase, we will test the machine to find the accuracy of the. Hello, I think somebody has asked something. Okay, we will proceed. So this is a training phase. During training phase, we will feed the available images of the different cars. Now, during the testing phase, we will test the accuracy of the algorithm. Okay, so in the machine, there will be a machine learning algorithm. Now, to the algorithm only, we will give the images of the cars, different types of cars. That phase is known as testing phase. Now, after testing, we will give, sorry, this will known as training phase. Now, after training phase, we will give some test data to test the accuracy of the algorithm. Now, after testing is over, after training and testing is over, and we found that the accuracy is somewhat up to the acceptable limit, we will give a new data. Now, if the accuracy is sufficient enough, the machine will predict or machine will classify it as a car. Now, this is how machine learns something. It is similar to how we human being learn something. Okay, so this is actually the machine learning process. So we want to give intelligence to the machine. So here, what we are trying to give is we are trying to make the machine capable of classifying an image as a car or not a car. Okay, so example, you assume that we want to train the machine in such a way that the machine is able to classify the given image as a car or not a car or no car. For that purpose, so what we should do is initially during the training phase, you feed some images of the car, different types of cars, images you give. This is known as training. Now, after the training phase, next comes the testing phase. During testing phase, some other images of the car will be given. Okay, then this phase is to check the accuracy of the algorithm. That means whether we have trained the algorithm properly. Now, during the testing phase, we will check the accuracy of the algorithm. And if it is found okay, so that means you are getting some accuracy of 90 percentage or more than 80 percentage. So that means our algorithm is able to classify the incoming image into car or no car. Okay. Now, if that accuracy is okay for you, then you give the image of a new car, then it will automatically predict it as a car. Now, if you give some other image, it will predict it as, actually, it is not prediction, it is classification. It will classify it as no car. If you give the image of a car, it will classify it as a car. And if you are giving some other vehicles, some bicycle, it will classify it into not a car. Now, this is the process that is happening inside the machine learning. I think this illustration is enough to give you an idea what is machine learning. Now we will go more into the machine learning. Now here is an illustration once again. Human being, I can learn everything automatically from experience. Can you learn? So he is asking the machine, can you learn something? I can learn something automatically from the experience. The machine replies, yes, I can also learn from the past data with the help of machine learning. So this is what is machine learning. So machine learns something from the past data with the help of machine learning. Then more into machine learning. What is machine learning? Enables a machine to automatically learn from the past data, improve performance with experience, and predict or classify things without being explicitly programmed. So this is actually the formal definition of machine learning. It enables a machine to learn from the data, improve performance with experience, predict things, predict or classify whatever be the operation, it will do that operation without being explicitly programmed. Explicitly programmed means much complex programming is not required. For machine learning, complex programming is not required. So this is the formal definition of machine learning. So we have seen it already. Now, what are machine learning algorithms? Machine learning algorithms actually deduce mathematical or logical models from the data, from the past data. Now, using these models, perform some decision making and solve tasks like prediction, classification, etc. Okay, so the machine learning algorithms actually what it does is it deduces some mathematical or logical models from the past data. This is what is the learning phase, the training phase. Okay, it will deduce the mathematical or logical models from the training data. Now after training, testing will happen. Now once we obtained good results using those models, we will have some operation like prediction, classification, etc., different tasks. Okay, so this is the uh, pictorial representation of the machine learning algorithm. The same explanation with the help of a diagram. In machine learning, the machine learning algorithm actually learns from the past data. That phase is known as training. Okay, learn from the past data. Now it will build some logical or mathematical models. Okay, now training, I have shown only training. We will do the testing also to check the accuracy. Now, after training and testing, we will get a good mathematical model, an accurate mathematical or logical model. Now, once we obtain that model, we will give the new data to have our prediction or classification. So, in the case of car or no car, see here I have shown you. Here the operation is classification. New car image will be given. New car image will be given, and the output will be it is a car or no car. If a different image is given, the output is no car. Whatever operation we require, you can do that operation there. Okay, so this is the uh, actually the essence of machine learning. Every machine learning algorithm. Okay, so after training and testing, a machine learning model will be created. We can say machine learning model will be created. A mathematical model or logical model will be created. Now the new input will be given to that model and get the output. Okay, similar to what we human being uh, does actually. Now we have been taught like when you are given with a new car, we can classify it as car or no car based on our experience because we have been taught like that with our instructors, by our instructors or by our parents. Okay. So in the same way, machine learning performs the operation. It may be classification, like car, no car, or it may be prediction. Depending upon the situation, the atmospheric situation, it may rain or uh, there won't be any rain. That is a prediction actually. So we will see it. Okay, based on different factors, the rain may come or not. It is actually a prediction task that can be also done by using the machine learning. So we will see it. Okay, different types of operation can be done by using machine learning. Any doubt up to this? Okay. Now here some more detailed picture which shows the machine learning. The same thing I explained. So here the past data will be there. So similar to this past data. Then as I told you, training data. The past data actually I told you there are two phases: training phase and testing phase. Now here only training phase has been shown. I told you one more phase is the testing phase. Okay, so this picture actually clearly shows the input data will be divided into training data and testing data. Okay, for example, you are given with some thousand data, thousand images. The thousand images we will divide into training and testing data. And there is a ratio there. We will see it later. How we will divide, we will see it later. Okay, so the input data will be splitted into training data and testing data. So testing data is for testing the accuracy of the model. Training data is to make the algorithm learn. Okay, now after training and testing done, we will get a machine learning model. Now, whenever a new data is given, it will produce some output. It may be prediction or classification. Now, this is the concept of machine learning. Okay, so I think this machine learning is okay for you. Now, first we have to split the input data into training data and testing data. Now, usually training data will be more in size because using this training data, we will train the algorithm. So it requires large number of data. Okay, so if the available data is 1,000 in numbers, now we will leave some 800 for training and the remaining 200 for testing. Okay, there is no such rule, but we will follow this particular rule. There is no such rule available. No strict rule is there. You can even have 700 uh, or 300, not a problem. But try to make this training data, number of training data, very much larger than number of testing data, because the training data should be large in number to make the algorithm learn properly. Okay, so for that particular thing, try to make training data more in number compared to testing data. Usually 80-20, 80-20, 80 percentage data will be training, used for training, and remaining 20 percentage will be used for testing, or 75-25, no issue, or 70-30, no issue. So usually these are the uh, recommended percentages in which we can split the data into training and testing. 70, 30 is also okay. Okay, so this 800 is 80 percentage and 200 is 20 percentage of 1000. So this is how we will divide the entire data into training and testing data. Now the machine learning algorithms. are broadly classified into supervised learning, unsupervised learning, and reinforcement learning. We will be concentrating on supervised and unsupervised. Reinforcement learning, we are not going into the details. Okay. We will be concentrating mainly on supervised and unsupervised learning. Okay, so machine learning algorithms are divided into supervised, unsupervised, and reinforcement learning. Now, first one, supervised learning. Now, up to this, any doubt? Okay, so first one, supervised learning. So, what is supervised learning? The name itself shows it is supervised learning. Supervised. That means we are giving both input and corresponding output. See, for example, assume that you want to uh, have a salary prediction algorithm, machine learning algorithm. For example, the input is we want to have a salary prediction algorithm. Okay, now you have the past data. The input is x. Assume that input is x, and x is the number of years of experience, number of years. Sorry, assume that the input is number of years, output is salary. Assume that we have this data for our employees. So assume that you are running a company and your employees, depending upon number of years, for example, the employee having 1 year experience will be given with a salary of 40,000. If the employee is having 2 year of experience, he will be given with a salary of 45,000. Assume. And if the employee is having 2.5 year experience, he will be given with 47,000 salary. And the employee having some 3 year of experience will be given with 50,000, say. Assume that only the number of uh, years of experience is the criteria. Assume that only we have the input is only number of experience, number of years of experience. And you assume that you are giving the salary depending upon the number of year of experience of each employee only. Okay, so this is the data we have now. The employer is having now, you are having now. Okay, now we want to make an algorithm, a machine learning algorithm, in such a way that whenever a new employee comes with an experience of some 4.5 year or some 2.2 year of experience, whenever a new employee comes with an experience of 4.5 years or 2.2 years. Okay, you want to make an algorithm so that the algorithm predicts the salary of this person having a 4.5 year of experience or the salary of this person having a 2.2 year of experience. You want to make an algorithm. So what you have to do is you have to train a machine learning algorithm. So in that you have to give both input. Input is the number of year of experience and the corresponding output. So that means we want to give both input and output, corresponding output, previous input and previous output, or already existing input and already existing output. Okay, so we are giving both input and corresponding output. See, for 1 year of experience, for this input, this is the output. For 40,000 is the output. For this input, 45,000 is the output. So, like that. Okay, so you are giving both input and corresponding output as the input to the supervised learning algorithm. Now here The input is both these input and output. We will give us input to the machine learning algorithm. So this type of algorithm is known as machine learning algorithm is known as supervised learning algorithms because we are supervising, we are giving supervision for this particular year of experience. This is the output. Okay, for this particular 2.5 year of experience, this is the output. This is the salary. So such kind of supervision we are giving in advance. Thereby, we are training the algorithm. So this type of machine learning algorithms are known as supervised machine learning algorithm. See, as I explained here, you can see this diagram. You can see here the input data. That means this data, input data. You can see. So here the input data in supervised machine learning algorithm, the input data contains both input and corresponding label. Label means the output. Okay, both input and corresponding output. So label is another name for output. So we will give both input and corresponding output as the data input to the machine learning algorithm. Okay, so now we will define the different terms for input and output. Input is the input data which is denoted by X, which is also known as feature. Input is also known as feature. Now the output is also known as label, which is the outcome, which is also known as target, represented by capital letter Y. Okay, you remember these terms. Input is also known as feature, denoted by X. Output is also known as label, denoted by Y. It is also known as target. Okay, so in supervised learning algorithms, we will give both input and the corresponding label, corresponding output as the input data to the machine learning algorithm, supervised machine learning algorithm. And we will train and test the data. I told you we have to divide the data into training data and testing data. Then we will train and test the model and we will produce a new model. And to the new model, a new, sorry, here a new, whenever a new input comes, it will produce an output. That's all. That means when we give 4.5 year of experience, it will produce the corresponding output, salary output. Or if you give 2.2 year of experience, it will give the corresponding salary output. So this is the operation in supervised learning. So this is the way in which supervised learning functions. Okay, so try to know this basic concept here in supervised learning. Supervised in the sense we will give corresponding input and corresponding output. We will give the input and corresponding output. So such kind of supervision we are doing, we are giving. So this is supervised learning algorithm. So I think this is clear to you. Any doubt up to this? Now, under supervised learning, we will have different categories. So we will see one by one later. This is just an introduction class only. We will take up this supervised learning and study different algorithms under this supervised learning later. Okay, so I think there are no clarifications required. So this is again a different illustration. I think this is not necessary. Okay. Mm. So here is the essence of the supervised learning algorithm. Now here we will give the input x and it will produce an output y, which is a function of x, which is a function of x. So this is how we will mathematically represent all the supervised machine learning algorithms. Okay, so that means here, as I told you, Here, initially, we will give some input and corresponding output. The algorithm learns from the data. So, learns from the data means it will produce some logical or mathematical model. Okay, so that is the function. It will find out some relation, the function between the input and output, the relation between the input and output. That is being shown here. Okay, based on the input and based on the relation between input and output, it will find out a function. This function is known as the model. This model means that particular function. Okay, so whenever a new input comes, using this function, we will have the operation. Okay, don't get confused. So we will see it later when we discuss the linear regression. At that time, I will be explaining about this function more clearly. Okay. So what do you mean by what is the meaning of this function? We will see later when we discuss the linear regression in detail, which is a supervised machine learning algorithm. We will see that later. Here x is the input, y is the output. So this x contains both year of experience and corresponding salary. Sorry. This x contains year of experience and the y contains salary. Okay, so this particular equation, that is y is equal to f of x, means it will find out the relation between salary and year of experience in this context. So when the input is year of experience and the output is salary, so this supervised learning algorithm will try to find out the relation between year of experience and salary. Now using that relation, whenever a new input comes, it will produce an output. Okay. Now, depending upon the nature of the output variable, it is also known as dependent variable or label, another name for output, which is a dependent variable because output depends on input. That is why it is known as dependent variable. Okay, or target variable or label or output, all are same. Okay, now depending upon the nature of the output variable, if the output variable is continuous, we can classify the machine learning supervised algorithms into two. If the output variable y is continuous, we will classify the supervised learnings into learning algorithms as a regression type of algorithms. If the output variable is categorical type, we will classify the supervised algorithms into classification type. Okay, once again, I will tell you, if the output variable is continuous, like output variable 1, 2, 3, 3.5, so like that, it is continuous, we will use regression type of supervised learning algorithms. If the output y is categorical, like car, no car, uh, car, no car, these are categorical, bus, jeep, etc. Okay, so these are categorical outputs. These are continuous outputs. Okay, so for continuous types of output variables, we will be using regression type algorithms. For categorical type of output variables, we will be using classification type of algorithms. All these comes under supervised learning algorithms. Okay, so supervised learning algorithms are classified into two types: regression type of algorithms and classification type of algorithms. So regression type of algorithms means here the input data will be the output data will be continuous in nature. So that means here also you can say it is 40,000, 50,000, 45,000, 47,000, 50,000, continuous in nature. Okay, but In case of the previous example, I have shown you car, no car. Okay, so that is categorical in nature. So that can be uh, given to classification type of algorithms. Okay, in order to classify an object into car, no car, we can use classification type of algorithms. And in order to have prediction type of operations like a salary prediction, a rain prediction, a temperature prediction, we can use these regression type of algorithms. So we will see one by one different regression types and different classification types. We will see later. Hands-on examples also, hands-on with hands-on experiments. Okay, so regression. First of all, regression. So I think this is clear to you. The supervised learning algorithms are classified into regression type and classification type. That's all. That is based on the nature of y. Y is the output variable. If the y is continuous, we can use regression type. If the y is categorical, we can use classification. That's all. Now regression type. Regression analysis helps to find out the prediction, help to predict something. Regression helps in the prediction of a continuous variable. Usually, prediction type of task will be done by using regression algorithms, and the classification type will be done by classification algorithms. Okay, all the prediction type of task will be done by using a regression type of algorithms, and all the classification type of task will be performed by using classification algorithms. Now, prediction of rain using temperature and other factors, determining market trends, prediction of road accidents due to rash driving. See, all these operations are prediction operations only. Prediction, prediction. Here also prediction of market trends. So all the prediction operation will be done by using a regression algorithms. Okay, now some examples are linear regression, regression tree, non-linear regression, uh, Bayesian, polynomial regression. So there are some examples we will see later one by one. Now we will be mostly using the linear regression only. We will be having hands-on on this linear regression later. Okay. Now classification. Here the operation will be classification. That means cancer detection, whether cancer is present or not, yes or no. So that type of yes or no classification is binary classification. So binary means 0 or 1. That is, 1 means it is yes, 0 means it is no. So that is yes or no classification. That means binary classification. Okay, so example cancer detection. Cancer, yes or no, is present or not, yes or no. So that type of classification is binary classification. See, it is performed when there is only two classes, yes class or no class. That classification is done by using binary classification algorithms. And if there is a multi-class classification is required, like plant classification, different types of plants, then that type of classification comes under multi-class classification. That means there are more than two classes, different type of trees, different types of different classes are there. So in that case, you can use multi-class classification. So we will see this classification in detail in our later sessions. So some examples are random forest, decision tree, logistic regression, support vector machines. All these algorithms are examples. So we will see one by one. All these uh, all these algorithms are important. So we will see mostly we'll be seeing these three. Support vector machine is also an important type of classification algorithm. So we will see, if time permits, we will see support vector machine also. Anyway, we will be seeing this random forest, decision tree, logistic regression detail in our following sessions. Okay. So this is all about supervised machine learning algorithms. Next comes unsupervised. Any doubt up to this? No doubt. Either you are understanding the whole thing or you are not understanding anything. Okay, anyway, I will proceed. Shall I proceed?
Yes, sir.
Okay, next type is unsupervised. Okay, now from the name, it is unsupervised. That means here you can see here in supervised case, we are giving both input and both previous input or existing input and corresponding output as the data to the supervised algorithms. But here in unsupervised case, here the data contains both only input. Once again, here in unsupervised case, the data contains only the input data. No corresponding label will be given. So that is the difference between supervised and unsupervised. That means here we are not giving any, we are not offering any supervision. Uh, the only the input is given. Corresponding label or corresponding output is not given to the algorithm. So that type of algorithm is known as unsupervised learning type of algorithm. Now, what it can do is it can cluster the inputs into different clusters based on the similarity. Now, it can easily find out the similarity between different input data points. Now, based on that similarity, similar data will be clustered together. See here, for example, input to 1, here input 4, input 2, input 9. All these are similar. So they are grouped into one cluster. Now, similarly, these inputs are similar, grouped into a different cluster. These inputs are similar, grouped into a different cluster. Like this, clustering operations will be done by using unsupervised learning. So, this is the only operation it can perform because there are no outputs available. Corresponding outputs are not available. Now, based on the similarity between input data, it will perform the clustering. Okay, so this is unsupervised case. So here, no label will be given as input to the algorithm or data to the algorithm. No label will be given as data to the algorithm. Now, it will understand the input data and form some groups or clusters from it. That is what is clustering will be done by using these types of algorithms. Now, here is an example, uh, an illustration. See, this is the data given, some illustrative example only, for illustration purpose only. Some apples, some other pear, I think, a different fruit. Then another type of fruit. Okay, so different fruits will be given as input, and this algorithm will form different groups or different clusters from the input. So this cluster belongs to this particular fruit. This cluster belongs to this fruit, and Similarly, this one also. So, like this, clustering will happen in unsupervised machine learning algorithms. Now, examples are K means clustering, hierarchical clustering, anomaly detection. Some examples are there. You can go through these examples. So, mostly we'll be seeing this K means and hierarchical. And the principal component analysis also, if time permits, we will see. And the singular value decomposition, SVD, is also available.